Section 16, question 6. Show that the point 510 lies on the circle with equation x plus 1 whole squared plus y minus 2 whole squared equals 100. We can show that the point lies in the line by subbing the point in, and if it satisfies the equation, then it lies on the line. So, where I see x, I'm going to replace it with 5, because that's the x coordinate. Where I see y, I'll replace it with 10. So that will give me 5 plus 1 whole squared plus 10 minus 2 all squared equals 100. That's 6 squared plus 8 squared equals 100. 6 squared plus 8 squared, well, 36 plus 64 is 100. So show that question, so I would just say LHS equals RHS. Therefore, point lies on line, on the circle. Part B says, find PQ rather is the diameter of the circle, as shown in the diagram. Find the equation of the tangent at Q. So to find the equation of tangent, it's a straight line right point gradient. I'm going to find first of all the point, which is Q. Now I can see that the circle centre is minus 1, 2. What I can next say is that vector Q, or rather vector Q, I'll call the circle centre T, is equal to vector TP, so QT equals TP. Now the object of the exercise here is to find Q. So T minus Q is equal to P minus T. Minus Q equals P, bring that across, minus 2T. So Q will be equal to minus P plus 2T just by changing the sign and everything. Q equals minus, I'm just going to find out what P is. So P is 0.510, so I'm just going to turn that into a column vector. Plus 2 lots of T, and T was the circle centre, which is minus 1, 2, and I'll change that into a column vector as well. So that's minus 5, minus 10, plus 2 lots of minus 1 is minus 2, 2 lots of 2 is 4. Minus 5 plus minus 2 is minus 7, minus 10 plus 4 is minus 6. So minus 7, minus 6, I can change that back into a point here. So I've got my point, now I'm looking to find the gradient of the tangent. So the tangent will cut the diameter at a right angle. So if I find the gradient of the diameter, I can do m1, m2 equals minus 1 and find the gradient of the radius. So mqp equals 10 minus 6. I could use the point T for this effect because that lies on the line, but I've used P. So 10 minus 6 over 5 minus 7. 10 minus 6 is 16, so it's 16 over 12, top and bottom be 4, and that will give me 4 over 3, so the gradient's 4 over 3. I've got the point, which is minus 7 minus 6, and I'll put that into y minus b equals m bracket x minus a. So that's y minus 6, which is y plus 6, is equal to 4/3 bracket x minus 7, which is x plus 7. Next I'm going to multiply through by 3, so it'll be 3y plus 18 equals 4 bracket x plus 7. It's 3y plus 18 is equal to 4x plus 28. bring the 18 across, make it minus, and that will be 3y equals 4x plus 10. Part C, two circles C2 and C3 touch circle C1 at Q. The radius of each of these circles is twice the radius of circle 1. Find the equations of circles C2 and C3. So here's what that scenario would look like. We know that the radius of both of these circles is double the radius of the original circle, which was C1. Next we can see is that that's r squared, so C1 has got a radius of 10, which means the radius of the two bigger circles then must be 20. Now we can also see that 5, 10, the point P, now serves as the circle centre for C3. So we should be able to now easily find the equation of that circle. We've got the circle centre and the radius. So that's x minus 5 all squared plus y minus 10 all squared is equal to the radius squared, 20 squared, and that's 400. So that's the equation of circle C3. Let's have a look at circle C2. It's also got a radius of 20. Now we need to find the circle centre. Now what we can see is that the vector AQ is equal to the vector QP. So the objective exercise with this one is to find the circle centre given by A. So that's Q minus A is equal to P minus Q. So minus A is equal to P minus 2Q, and change the sign and everything, A is going to be equal to minus P plus 2Q. P, as you can see, is given by 510, so A is equal to minus, open up 510, plus 2 lots of Q, which we've already worked out. Q was the point minus 7, minus 6. So that's minus 5, minus 10, plus 2 times minus 7 is minus 14, 2 times minus 6 is minus 12. So minus 5 plus minus 14 is minus 19, minus 10 plus minus 12 is minus 22. So the circle then, centre then, for that one, I can write that as a point minus 19 minus 22. I know that the radius is equal to 20, and I can now put that into x minus a all squared. So x minus minus 19, x plus 19 all squared, plus y minus minus 22 all squared, that's y plus 22 all squared, is equal to 20 squared, and that's 400, that's the final answer.